Deep learning is a rapidly evolving field of artificial intelligence that has revolutionized the way we approach various problems in business. So, today we'll provide a comprehensive A to Z glossary of deep learning terms, explaining them in simple terms and highlighting their relevance to business applications. So, let's start with activation function. Now, this activation function in the context of business applications is a mathematical formula that determines whether a particular input is considered active or inactive for a particular decision making process. In other words, it helps to decide whether a specific variable or data point is relevant or not when making a business related decision. For example, let us say you are a marketing manager for a clothing store and you want to determine which products to promote in your next advertisement campaign. You have a data on the popularity of different products such as the number of units sold, customer reviews and social media mentions. Now here the activation function can help you decide which products are the most popular and should be prioritized in your advertisement campaign. Now the function would take in this data point and output a value that indicates how active or relevant each product is for the campaign. And this output can be used to sort and rank the products so that you can make informed decisions about which ones to feature in your advertisement. So to summarize this, we can say that this activation function, it's a mathematical tool that helps business make data-driven decisions by evaluating the relevance of input data points and assigning a value to them. And this value can be used to inform decision-making processes such as prioritizing which products to promote in the marketing campaign. Next comes the backpropagation algorithm. Now this backpropagation algorithm, it's a mathematical method used in machine learning to adjust the parameters of neural network in order to improve its accuracy in making prediction. And in the business context, this algorithm is often used in applications such as predictive analytics, where the company wants to make prediction about future events based on historical data. So to understand this backpropagation, let us consider an example. Let us say you are a credit card issuer and you want to develop a model that can predict whether the customer is likely to default on their payments. And you have a data on various factors such as credit score, income and payment history. Now here, this backpropagation algorithm can help you train a neural network to make accurate predictions about that future defaults based on this data. And this neural network is made up of interconnected nodes that process the input data and make a prediction. And this algorithm works by feeding the input data through a neural network and compare the predicted output to the actual output. So here in this case, whether the customer is defaulted or not, we'll check that. So the difference between the predicted and actual outputs is then used to adjust the parameters of neural network to make it more accurate. And this process is repeated over and over with the network continuously adjusting its parameters until it can make accurate predictions. So this backpropagation algorithm make this adjustment process possible by propagating the error back through the network, allowing the network to adjust its parameters in the right direction. So to summarize this, we can say that this backpropagation algorithm is a powerful tool for training neural networks to make accurate predictions in business applications. And it is particularly useful for predictive analytics tasks, where the company wants to make predictions about future events based on historical data. Next comes the convolutional neural network. So these convolutional neural networks are a type of neural network which are used in machine learning specifically for image and video recognition tasks. So in the context of business application, these convolutional neural networks are often used to analyze and classify images, such as product image on an e-commerce site or video footage from the security camera. So to understand how a CNN works, let us consider an example. Let us say you are an e-commerce company and you want to develop a system that can automatically classify product images into categories such as clothing, electronics, or home goods. So here the CNN works by taking an image as an input, breaking down into the smaller parts, and then analyze each part to determine its features. And then these features are used to classify the image into a particular category. Now this CNN consists of multiple layers, with each layer performing a specific task. So the first few layers of the CNN will learn to detect simple features such as edges and lines, while the deeper layers will learn to detect more complex features such as shapes and patterns. And as the image is fed through the layers, the features are extracted and the network predicts the category of this image, and then this prediction is compared to the actual category, and the network adjusts its parameters to improve its accuracy. So for adjusting the parameters of the networks, we can use backpropagation algorithm, which we just discussed. So to summarize this, we can say that this convolutional neural networks are a powerful tool for image and video recognition tasks in business applications, and they are particularly useful for tasks such as product categorization, quality control, and security monitoring. Now next comes the deep learning. So this deep learning is a subset of machine learning that involves training deep neural networks with multiple layers to perform complex tasks. And in the business context, deep learning is often used to develop intelligent systems that can analyze and make decisions based on large amount of data. So to understand deep learning, let us consider an example. Let us say you are a retailer and you want to develop a system that can automatically identify which products on your website are most likely to be purchased by a customer based on their browsing history. So here the deep learning will involve training a neural network, which is a series of interconnected nodes, to analyze the customer's browsing history and make a prediction about which products they are most likely to purchase. So this neural network is trained using a large data set of customer browsing history and purchase data. So the network is initially presented with this data and makes prediction about which products the customer is likely to buy. Here the predictions are then compared to the actual purchases made by customer, and the network parameters are adjusted accordingly. And this process is repeated multiple times, with the network continuously adjusting its parameters to improve its accuracy. So this deep learning algorithm used to adjust the parameters is typically the backpropagation algorithm, and the result is a high accurate system that can predict whether the product or the customer is likely to purchase based on their browsing history. So this information can be used to personalize product recommendations, improve the customer experience, and ultimately increase the sales. So to summarize this, we can say that deep learning is a powerful tool for developing intelligent systems that can analyze and make decisions based on large amount of data in business applications. And it is useful for the tasks such as personalized product recommendation, fraud detection, and image recognition. Now next comes the epoch. So in the context of machine learning, an epoch refers to a complete pass through the training data. And in simple terms, we can say that it is the number of times the algorithm goes through the entire data set during training. So to understand epochs in a business context, let us consider an example. Let us say you are a financial analyst and you want to develop a model that can predict whether the loan applicant is likely to default on their payments. So this machine learning algorithm is trained using a large data set of loan applications, including information such as credit score, income, and loan amount. So here the algorithm goal is to learn the patterns in this data that can predict whether a loan applicant is likely to default. So during the training process, the algorithm goes through the data set multiple times, and each time it goes through the entire data set, it's called an epoch. And at the end of each epoch, the algorithm evaluates its performance on a separate validation dataset, and the hyperparameters are adjusted to improve its accuracy. So as the algorithm continues through more epochs, it becomes better at identifying the patterns in the data that are important for making accurate predictions. So to summarize this, we can say that epoch is a complete pass through the training data in machine application models. And in business applications, it's a way to measure the progress of model during the training process, allowing for adjustments to be made to improve its accuracy. Next comes the feed-forward neural network. So this feed-forward neural network, it's a type of neural network where the data flows from the input layer to the output layer in a single direction. So in simple terms, it's a series of interconnected nodes that process information from input to the output. So to understand this feed-forward neural network in business context, let us consider an example. So let's say you are an e-commerce company and you want to develop a system that can predict the likelihood of a customer making a purchase based on their browsing history. So here the feed-forward neural network will take the customer's browsing history as input and will process it through the series of the nodes in the network. So the first layers of the node will process the raw data, and the output of these nodes is passed to the next layer of the nodes, and this process continues until the final output, which produces a prediction of the likelihood of the customer making a purchase. So each node in the network will perform some operations such as multiplication or summation and applies an activation function to produce an output. So here the activation function will determine the shape of this output and helps the network learn complex patterns in the data. And the weight of the connections between the nodes are adjusted during the training process, which allow the network to learn the patterns in the data that are important for making accurate predictions. So to summarize this, we can say a feed-forward neural network is a type of neural network that process information from the input to the output in a single direction. And in business applications, it's commonly used for tasks such as customer behavior prediction, fraud detection, and predictive maintenance. Next comes the gradient descent. So this gradient descent, it's a powerful algorithm which is used in machine learning to adjust the parameters of model during the training process. And here the goal is to find the set of parameters that minimizes the loss function. So which measures how well the model's prediction matched the actual outcomes. So to understand this gradient descent in a business context, let us consider an example. So let us say you are a marketing manager and you want to develop a model that can predict customer response to different marketing campaigns. So here this machine learning algorithm will use a set of parameters to make prediction about customers' response. And the goal of gradient descent is to adjust these parameters to minimize the difference between the predicted response and the actual response. So here the algorithm will start with the initial set of parameter values and then will calculate the loss resulting from these values. It will then calculate the gradient of this loss function, which is the measure of the direction of steepest increase in the loss. And this algorithm will adjust the parameters in the opposite direction of gradient, effectively moving towards a lower loss. And this process is repeated multiple times, with the algorithm continuously adjusting the parameters to minimize the loss that can make accurate predictions about the customer's response to different marketing campaigns. So to summarize this, we can say that gradient descent is a powerful algorithm which is used in machine learning to find the set of parameters that minimize a loss function in a model. And in business applications, it's used to develop accurate models for tasks such as customer response prediction, fraud detection, and predictive maintenance. Now next comes the hyperparameters. So these hyperparameters are settings used to control the behavior of a machine learning algorithm. So they are parameters that are set before the training process begins and influence the process of the model. So to understand hyperparameters in business context, let us consider an example. Let's say you are a data scientist and you are developing a machine learning model to predict whether the customer will churn a service or leave a service. So here these hyperparameters in this model could include the learning rate, the number of hidden layers in the neural network, and the number of neurons in each layer. So this learning rate would control how quickly the model adjusts its parameters during the training process. And number of hidden layers and neurons will determine the complexity of model. So before training the model, you could choose those hyperparameters based on your knowledge of the problem, the data, the previous experience. And these hyperparameters will influence the behavior of the model during training process and ultimately affects its process on the performance on the text data. So during the training process, the algorithm will adjust the parameters, that is the weights and bias of the models, to minimize the loss function, and the hyperparameters remain fixed throughout this process. So to summarize this, we can say that these hyperparameters are the settings that control the behavior of this machine learning algorithm. And in business applications, they are used to develop accurate models for tasks such as customer churn prediction, fraud detection, predictive maintenance. So by choosing the appropriate hyperparameters, you can improve the performance of your model and make better predictions. Now next comes the image recognition. So this image recognition, it's a machine learning technique that enables computers to identify and interpret the objects within an image. And it is a powerful tool which is used in business applications to automate tasks, streamline processes, and enhance the customer experience. So let us consider an example to understand image recognition in the business context. So imagine you are a retail manager and you want to develop a system that automatically counts the number of people in your store at a given time. So here the image recognition system will use a camera to capture images of your store. And these images are then fed into the image recognition algorithm, which will analyze the images and will identify individual people. Now this algorithm will count the number of people in each image and will provide you with the accurate count. So this image recognition system can be used for various applications such as optimizing staffing, managing inventory, and monitoring customer behavior. And by automating the process of counting people, you can save time, reduce labor cost, and gain valuable insights into your store's traffic pattern. So to summarize this, we can say that image recognition, it's a machine learning technique that enables computers to identify and interpret objects in an image. In business applications, it's used to automate the task and enhance the customer experience. An example of business applications includes people counting, facial recognition, and product identification. Then comes the Jupyter Notebook, which is a powerful tool that enables data scientists, analysts, and business professionals to create, share, and collaborate on documents that contain live codes, equations, visualizations, and narrative tasks. And it's an open source web application which is used for data analysis, machine learning, and scientific computing. So to understand the Jupyter Notebook in the business context, let us consider an example. Imagine you are a data analyst working for a financial service company and you have been tasked with analyzing customer transaction data to identify patterns and trends. So using the Jupyter Notebook, you can write code in a Python programming language to read the transaction data, perform various statistical analysis, and then visualize the results using graphs and the charts. So this Jupyter Notebook will allow you to write the narrative text describing your analysis alongside the code, making it easy to explain your methods and findings to stakeholders. So this Jupyter Notebook also enables collaborations among team members. You can share your notebook with your colleagues who can review your work, run your code, and make comments directly in the notebook. And this collaboration feature makes it easy to work together on complex projects and share knowledge within your team. So to summarize this, we can say that Jupyter Notebook, it's a powerful tool for data analysis, machine learning, and scientific computing. In business applications, it's used by data scientists, analysts, and business professionals to create, share, and collaborate on documents containing live codes, equations, visualizations, and narrative text. So this Jupyter Notebook will make it easy to explain and share your work, which enables effective collaborations and communication within your team. Next comes the Keras. Now this Keras is a user-friendly open source library which is used for developing and training deep learning models. It's written in Python and can run on top of either TensorFlow, Theano, or CNTK. So this Keras is designed to make it easy to build and train neural networks while providing the flexibility to customize and optimize your models. So to understand Keras in the business context, let us consider an example. Imagine you are a data scientist working for an e-commerce company, and you have been tasked with developing a machine learning model that can predict the likelihood of a customer making a purchase based on their browsing history. So using Keras, you can design a neural network model with several layers, including an input layer, hidden layer, and an output layer. So here the input layer will take in data such as the products viewed, the time spent on the website, the items added to the cart. And this hidden layer will process this information and will extract the relevant features. And finally, the output layer will produce a prediction such as likelihood of the purchase. So this Keras, it simplifies the process of building and training neural networks by providing a high-level interface. So you can easily define your model, specify the layers, set the activation function, and train the model using pre-built functions and methods. So to summarize this, we can say that Keras is a powerful library which is used for developing and training deep learning models. And in business applications, it's used by data scientists, analysts, and business professionals to build predictive models for a wide range of applications, including customer behavior analysis, fraud detection, and predictive maintenance. And this Keras makes it easy to design, train, and optimize complex neural networks, which allows you to develop accurate models quickly and efficiently. Now next comes the long short-term memory. So this long short-term memory, it's a type of recurrent neural network which is used for processing sequential data such as time series data, speech recognition, and natural language processing. And these long short-term memories are particularly useful in business applications where the model needs to learn from historical data when making the predictions. So to understand LSTM in business context, let us consider an example. Imagine you are a marketing analyst and working for an online news publication where your task is to develop a predictive model that can forecast the number of views for a news article based on its content, the time of the day it was published, and the trending topics of the day. So this LSTM model will take in historical data such as the number of views for previous articles on similar topics, the day of the week, the time of the day. So these LSTM layers will process this information, will learn the relations between the features and the number of views, and then the model will make predictions about the number of views for a new article based on its content and the current trending topics. So these LSTMs are particularly useful in business applications because they can remember information over a long time and can make predictions based on the context and history. For example, in the news article, so here the LSTM can learn that certain topics tend to be popular at certain times of the day and can adjust its prediction accordingly. So to summarize this, we can say this long short-term memory are a type of recurrent neural network used for processing sequential data. In business applications, they are used to analyze and predict trends in various domains such as customer behavior, stock prices, and website traffic. And they are useful for tasks that require the model to learn from historical data and make predictions based on the context and history. Now next comes the mini batch gradient descent. So this mini batch gradient descent, it's a method used in machine learning to adjust the parameters of model during training. Basically, it's an optimization technique that helps the model learn from data and improve its performance. So to understand this mini batch gradient descent in a business context, let us consider an example. Imagine you are a marketing analyst and working for a retail company where your task is to develop a predictive model that can estimate the demand for a particular product based on its historical sales data. So here the model's parameters such as the relations between the price of product, the season, the demand are initially set randomly. And the goal is to adjust these parameters in order to minimize the difference between the predicted and the actual demand. So here this mini batch gradient descent is used to iteratively adjust these parameters. So instead of using all the data points or the observations at once to update the parameters, mini batches of data are used. So this mini batch, it's a small subset of data, typically ranging from 2 to 32 observations. So in each iteration, the model will process a mini batch of data, will calculate the error in prediction, and then will adjust the parameters to reduce the error. And then this process is repeated multiple times over the entire data set, which allow the model to learn from the data, improve its predictions. So using mini batches instead of entire data set for each iteration helps the model converge faster and it's computationally more efficient. It also allows the model to learn from data in a more robust way by considering the relations between the different data points. So to summarize this, we can say that mini batch gradient descent, it's an optimization technique which is used in machine learning to adjust the parameters of models during training. And in business applications, it is used to develop predictive models for a wide range of tasks such as demand forecasting, sales predictions, and fraud detection. And this mini batch gradient descent helps the model learn from the data in an efficient and effective manner, leading to improved performance and accuracy. Now next comes the neural networks. So this neural network, it's a type of machine learning model which is inspired by the structure and function of human brain. And it is a series of interconnected nodes or neurons, much like the neurons in our brain. And these nodes will process and transmit information in a hierarchical manner to make predictions or decisions. So to understand neural network in business context, let us consider an example. Imagine you are a financial analyst working for a bank, where your task is to develop a model that can predict whether a loan applicant will default on their loan payment. So here the neural network model will take in data points such as the applicant's credit score, its income, employment history, and the loan terms as input. And these inputs are processed through a series of interconnected nodes organized into layers. So the first layer or the input layer will take the raw data and pass it to the next layer, which are the hidden layers. So these hidden layers will process the information using mathematical functions such as multiplication, addition, and activation function. So this activation function will introduce non-linearity, which allow the model to learn more complex relations. And finally, the final layer or the output layer will produce the prediction such as likelihood of default. And this prediction is based on that information which is passed through the hidden layers. So these neural networks are particularly useful in business applications because they can learn complex relations from large data sets. For example, in the loan default example, so neural network can learn the intricate relations between the credit score, income, employment history, loan terms to make the accurate prediction about the likelihood of default. So to summarize this, we can say that this neural network are a type of machine learning model inspired by the structure and function of human brain. And in business applications, they are used to develop predictive models for a wide range of tasks such as loan default prediction, customer churn prediction, and stock price prediction. And these neural networks allow business to identify complex relations in data, which leads to improved predictions and decision making. Then comes the overfitting. So this overfitting is a problem that can occur when developing machine learning models. And it is crucial to understand this concept from the business application perspective. So normally this overfitting occurs when the model is too complex and memorize the training data instead of learning the underlying pattern. So as a result, the model performs well on the training data but performs poorly on the new unseen data. So to understand overfitting in the business context, let us consider an example. Imagine you are a marketing analyst who is working for e-commerce company, where your task is to develop a predictive model that can estimate the likelihood of customer making a purchase based on their browsing history. So let us say you built a model that has a very high number of features, such as number of pages visited, the time spent on each page, the products reviewed, and the products added to the cart. And this model is so complex that it can capture every single detail of the training data. So during the training phase, the model performs exceptionally well, accurately predicting the likelihood of customer purchasing the data it has seen. However, when the model is evaluated on new unseen data, it struggles to make accurate predictions. So issue here is that model has overfit the training data, has memorized the patterns instead of learning the underlying relations. And this overfitting can lead to poor performance when the model is deployed in real world scenario. So to avoid overfitting, you can use techniques such as regularization, early stopping, or reducing the complexity of model by removing features. And in the e-commerce example, you might simplify the model by removing less relevant features such as the time spent on website and focus on more critical features such as the products viewed and added to the cart. So to summarize this, we can say overfitting occurs when a machine learning model is too complex and memorizes the training data instead of learning the underlying pattern. And this problem can lead to poor performance on unseen data. In business applications, it is crucial to understand and address overfitting to develop models that can make accurate predictions and inform business decisions. Now next comes the pooling layer. So this pooling layer, it's a component of neural networks specifically used in convolutional neural networks, which are a popular type of neural network in image recognition and other applications. So this pooling layers, it helps simplify the information and reduce the computational cost of the network while retaining important features. So in the context of business application, let us consider an example of CNN being used for fraud detection in credit card transaction. So this CNN will take image-like representation of credit card transaction, that is a sequence of the transaction amounts, time spent as input, and will process it through the network. So this pooling layer, it's often called a downsampling layer. It operates on the output of convolutional layers, where it performs a summarizing operation such as taking the maximum or the average value over that rectangular region. And this summarizing operation reduces the special dimensions of output from the convolutional layers, which helps simplify the information and reduce the computational cost of the network. For example, a pooling layer might take a 5x5 region of the output from the convolutional layer and then output a single value, that is the maximum value in that 5x5 region. And this process is repeated across the entire output from the convolutional layers, which results in a reduced size output that retains important features. So to summarize this, we can say that pooling layers are an essential components of convolutional neural networks, which are used to simplify the information and reduce the computational cost of the networks while retaining important features. And in business applications, they are used in image recognition tasks such as credit card fraud detection to develop models that can learn and identify the patterns in complex data. Now comes the quantum machine learning. So this quantum machine learning is a relatively new field that combines the principles of quantum computing and machine learning. So while the technology is still evolving, its potential to revolutionize this machine learning has garnered significant attention from business. So imagine a machine learning model as a puzzle solver who is trying to find the best solution to a problem using a vast data set. So in classical machine learning, this puzzle solver is limited by the computational power which is available on classical computers. While this quantum computers, on the other hand, they have the potential to solve these puzzles much faster due to the unique properties of quantum bits. So this in quantum machine learning, quantum computers perform operations on these quantum bits, which can be in a superposition of multiple states simultaneously. And this property allows them to explore multiple solutions to a problem in parallel, which increases the speed of computational processes. And from the business application point of view, this quantum machine learning has a potential to significantly improve the efficiency and effectiveness of machine learning algorithms. For example, in finance, this quantum machine learning could be used to analyze vast amount of financial data to identify the patterns and anomalies that classical computers might miss. And this could enable better risk assessment, fraud detection, and investment strategies. Another example is in healthcare, where this quantum machine learning could be used to analyze this genomic data, which can help researchers identify the genetic markers for disease, which could lead to the development of more effective treatments and personalized medicines. So while the technology is still in its early stage, businesses have started to invest in this field. So to summarize this, we can say that quantum machine learning is a field that combines quantum computing with machine learning. And by leveraging the unique property of quantum bits, it has the potential to significantly improve the efficiency and effectiveness of machine learning algorithms. So from financial analysis to personalized medicine, it has the potential to revolutionize the business applications in various industries. Now comes the rectified linear unit. So this rectified linear unit are a type of activation function which is used in artificial neural network, which are the backbone of machine learning models. So these activation functions are used to introduce non-linearity into the neural network, which allows it to learn more complex patterns in data. So think of this rectified linear unit as a single mathematical function that activates the output of neuron. So in a neuron, inputs are multiplied by learnable weights and then passed through activation function before producing a neuron's output. So imagine a business application such as a fraud detection system, where the neural network is trained to recognize the fraudulent transaction. So each neuron in the network will process the information and then will output a value, which is then passed through a ReLU activation function. So here this ReLU activation function will work by taking the input value and simply outputting the input if it is positive or 0. It will say 0 if it is negative. It will say positive if there is an input. So in mathematical terms, it can be say like max of 0 or input. So here let's understand how this ReLU works. So first the neuron will receive input values and then multiply them by learnable weights. And then these weighted inputs will be summed and passed through the ReLU activation function. So if the output is positive, it shall be passed through unchanged. If the output is negative, it shall be set to 0. So using rectified linear unit helps the neural network learn complex patterns by enabling it to focus only on that positive inputs while ignoring these negative ones. This is important in business applications where the neural networks can be used to identify patterns in complex data such as customer behavior, market trends, and financial data. So to summarize this, we can say this rectified linear unit, they are activation functions which are used in neural network to introduce non-linearity and enable the network to learn complex patterns in data. And in business applications, they are crucial component of machine learning models that can help business gain insights from vast amount of data and can make informed decisions. Now next comes the stochastic gradient descent. Well, this is a powerful and popular optimization algorithm which is used in machine learning to train models including neural network, where the goal of training is to find the set of weights that minimizes the loss function, such as the difference between the predicted and actual values. So imagine you are a business owner and you want to optimize your marketing strategy, where your goal is to maximize revenue by finding the right balance of advertisement or advertising spend on different channels such as social media, television, and print ads. This is similar to finding the optimal weights in a machine learning model. So this stochastic gradient descent is like a step-by-step process that helps you find the optimal weights one step at a time. So it works by adjusting the weights of models in small increments based on the impact of the loss function. So imagine you have a set of customer data including their demographics and the amount they spend on your products. So you have also created a model that predicts how much a customer will spend based on this data. So this loss function will measure the difference between the predicted and actual spending. And the stochastic gradient descent will work by iteratively updating the weights of model in the direction that minimize the loss function. So to understand how it works in a layman term, let's understand you will start with the initial set of weights for your model. Then you will choose a small subset of your customer data such as single customer and use it to calculate the loss associated with that current weight. And then we'll update the weights in a direction that will decrease the loss, and then we'll repeat the steps for multiple iterations. So this stochastic part of the stochastic gradient, so it means that it uses a single data point at a time to update the weights rather than using the entire data set at once. and this approach is computationally efficient. So to summarize this, we can say that stochastic gradient descent, it is an optimization algorithm which is used to find the optimal weights in a machine learning, and it works by iteratively adjusting the weights in a small increments based on the impact of the loss function to minimize the difference between predicted and actual values. And in business applications, it's used to optimize marketing strategies, pricing models, and other decision making processes based on data. Now comes the transfer learning. So this transfer learning, it's a powerful machine learning technique that allows you to leverage the knowledge gained from training one model to another similar model. This is like using the insights gained from analyzing one business problem to solve a related problem in another context. So imagine you have a business that sells products online. You have trained a machine learning model to predict which products customers are more likely to buy based on their browsing history and purchase history. So this model has learned valuable information about your customers' preferences and buying habits. Now suppose you start a new business in a related field such as selling similar products on different platforms. So here you can use transfer learning to leverage the knowledge gained from previous model to quickly train a new model for this new business applications. So where this transfer learning will work by pre-training a model, then will freeze the weights and then unfreeze the weights. So by using transfer learning, you are essentially borrowing the knowledge which is gained from the first model to speed up the training process for the second model. So in business applications, this can be used to adapt a customer's recommendation system for new product line, or to fine tune a natural language process, or to transfer knowledge from a stock market prediction model to different similar model for the different market. So to summarize this, we can say that this transfer learning, it's a powerful technique that allows you to capitalize on the knowledge gained from solving one problem to solve a similar problem more efficiently, ultimately saving time and resources while improving the performance of your machine learning models. Now next comes the underfitting. So this underfitting, it's a common problem in machine learning that occurs when a model is not able to capture the complexity of the underlying relations between the input variables and output. So it is like trying to fit a simple puzzle with too few pieces to accurately present a complex image. So imagine you are a business owner and you are trying to predict the demand of your product based on the historical sales data. And you decide to use a simple linear regression model which uses a straight line to fit the relations between the number of days since the start of the year and the sales volume. However, you soon realize that the model is not performing well because the predicted sale volumes are consistently lower than actual sales, which means that the linear model is not flexible enough to capture that complex patterns in data. So this is an example of underfitting, which occurs when the model is too simple to accurately capture the underlying relations in data. As a result, the model has poor performance on both training and test data. So in layman terms, the underfitting is when the model is too basic to capture that intricate patterns and relations in data, which can lead to inaccurate predictions and poor understanding of underlying problem. And in business applications, underfitting can happen in scenarios such as using a simple linear regression model to predict the customer churn, when a more complex model such as decision tree or neural network is needed, or when you are applying a basic pricing model that doesn't account for seasonal trends, competitor prices, and other factors. Or third, you are using a simple forecasting model for stock prices that does not amount for economical indicators. So to overcome this underfitting, you can try using a more complex model, adding more features of variables to the existing model, or increase the model's capacity by adjusting the hyperparameters such as number of hidden layers in the neural network, where the key is to find the right balance between model complexity and model performance. Now next comes the variational autoencoder. So this variational autoencoder, it's a powerful machine learning technique that combines the strength of autoencoders, which is a type of neural network, and Bayesian methods. So it's like using a magician's hat to create a visually appealing and informative representation of your business data. So these autoencoders, they are neural network that learn to compress complex data into a lower dimensional representation such as latent space. So in the case of variational autoencoder, the autoencoder is designed to learn a probabilistic representation of data, which allows for the generation of new data samples. So it can be used for data compression and dimensionality reduction. For example, you can use the variational autoencoder to compress customers' data while retaining the important information about the customer behavior, preference, and demographics. Then it can be used for generative modeling, where it can be useful in the business scenarios where generating realistic synthetic data can be useful for testing and evaluating new strategies, such as generating hypothetical customer profiles for testing marketing campaigns. And then it can be used for representational learning. So for example, a variational autoencoder could learn a compressed representation of customer behavior that highlights the common patterns and trends across different customer segments, or it can be used in probabilistic modeling. So to summarize this, we can say this variational autoencoders, they are a powerful machine learning technique that can help business to better understand and work with their data, from compressing and reducing dimensionality to generate new data samples by learning representations and probabilistic modeling. So by leveraging this variational autoencoders, these businesses can gain valuable insights and can make more informed decisions based on their data. Now next comes the weight initialization. So this weight initialization, it's a crucial step in the training of machine learning models, particularly in the neural networks. So it's like choosing the right tool for your toolbox to ensure that your models are well equipped for the task at hand. So when you train a neural network, so first the model starts with randomly initialized weight for the connections between neurons. And then this process of training involves adjusting these weights to optimize the model's performance. However, if the initial weights are not chosen appropriately, then the training process can become inefficient. So in business applications, this weight initialization is important for efficient training. For example, in recommendation system, a well-initialized neural network can learn to predict better user preference, which can lead to more accurate and personalized recommendation. Then it can also be used to avoid bias and variance issues. So that is key. By initializing the weights appropriately, you can ensure that each neuron is contributing to model performance, which can lead to more balanced and effective model. Then it can be used in deep neural network. So by properly weight initialization can help alleviate the issue of vanishing gradient, which can enable the efficient training of deep neural networks. Then it can be used for the generative models. So you can ensure that the model can learn the underlying data distribution and can generate synthetic data resembling to the original data. So to summarize this, we can say that this weight initialization, it's a crucial step in training machine learning models, particularly neural networks. So by choosing the appropriate initial weights, you can ensure the efficient training, avoid bias and variance, and can improve the performance of your model in various business applications. Now next comes the Xavier initialization. It's also called Glorot initialization. Basically, it's a technique for initializing the weights in neural network. So it's like choosing the right size nail for your hammer to ensure that your models are well prepared for the task at hand. And the idea behind this Xavier initialization is to choose initial weights that are neither too small nor too large. And this can lead to the issues during the training process. So specifically, it helps to maintain the balance of the activation gradients which is flowing through the network during backpropagation, ensuring that the gradients are neither vanishing nor exploiting. And in neural networks, each neuron will receive weighted inputs from the previous layer, and then weight will determine the impact of each input on the neuron's output. So this in business applications, the Xavier initialization can be used for deep neural network. For example, a well initialized deep neural network could learn to better predict user preference and recommendation system, which can lead to more accurate personalized recommendations. Then it can be used in the recurrent neural networks. So by initializing this recurrent neural network with the Xavier weights, you can ensure that model can learn and process information from distant points in the sequences. Then it can be used in generative models to ensure that generative model learn the data distribution effectively. So to summarize this, we can say that the Xavier initialization, it is a specific technique for initializing the weights in neural network that helps to maintain the balance of activation gradients during the training process. So by initializing the weights properly, you can ensure efficient training and can avoid issues like vanishing gradient and can improve the performance of your models in various business applications. Now comes you only look once, or the YOLO architecture. So which is a powerful and popular computer vision algorithm. So it is used in some business applications like object detection, surveillance, and augmented reality. So it is like using a fast and accurate tool to find specific items in crowded image, such as products in online store or people in a security camera feed. So this YOLO, it is a convolutional neural network architecture which is designed to detect objects in images or videos, and it stands out from other object detection algorithms because of its speed and accuracy. So it has basically two key optimizations. First is a single network architecture, where the YOLO uses a single convolutional neural network to predict bounding boxes and the class probabilities for that object in an image, unlike other algorithms that uses a pipeline of multiple networks. So this single network architecture is computationally efficient and can process images in real time. Then comes the direct regression. So instead of using the complex feature extraction and post-processing techniques, YOLO directly predict the bounding boxes and class probabilities. So in business applications, it can be used for object detection in images, like it is used in online shopping applications to detect products in images, which enables the users to easily find and purchase products they see in the images. And it can also be used in art and historical image database to automatically identify and categorize objects. Then it can be used in real-time video surveillance. So where it can be used in security system to detect and track objects in real time, such as people, vehicles, or other potential threats. And this can be used in surveillance cameras, retail stores, or parking lots to monitor activity and ensure safety. Then it can be used in augmented reality, so where it can be used in applications like furniture visualization, so where user can see how a particular piece of furniture would look in their home before purchasing. And then it can be used in face and facial feature detection, where it can be used in applications like social media platforms, security system, and video conferencing. So to summarize this, we can say this YOLO, it's a fast and accurate computer vision algorithm which is used in a wide range of business applications such as object detection, surveillance, and augmented reality. So its single network architecture and direct regression approach makes it computationally efficient and suitable for real-time applications. And then comes the zero-shot learning. So the zero-shot learning, it's a technique in machine learning that allows a model to recognize and classify objects, concepts, or images it has never seen before, only using the textual descriptions or attributes. So it's like having a language model that can understand and describe objects based on the words and phrases, even if it has never seen a picture of that object before. So in business applications, the zero-shot learning can be used to solve various problems such as image classification. So the zero-shot learning can be used in image classification, where model is given textual description of objects and their categories. For example, in an e-commerce application, you can use zero-shot learning to classify images of products by their textual description, such as blue t-shirt or red sneakers. So this helps in organizing and categorizing the products, which makes it easier for users to find what they are looking for than in the text-based retrieval. So here, zero-shot learning can be used in text-based retrieval tasks. For instance, in a search engine for images, you can use zero-shot learning to search for images based on textual descriptions, such as pictures of New York City skyline, which helps user find relevant images without having to rely solely on visual similarity. Then it can be used in attribute based recommendations. So the zero shot learning can be used in recommendation system. For example, in an online fashion store, you can use zero shot learning to recommend clothes to customers based on the textual attributes like comfortable, breathable, stylish. So this helps customers find items that match their preferences and needs, even if the items have never been recommended before. Then it can be used in multilingual image recognition. So here the zero-shot learning can be used in multilingual image recognition, for example, in applications like social media platforms, where users can tag images in their native language, which makes it easier for users to find and share content in their language. So to summarize this, we can say that zero-shot learning, it's a powerful technique in machine learning which allows models to recognize and classify objects, concepts or images that they have never seen before using only textual descriptions or attributes. So in business applications, it can be used to solve a wide range of problems such as image classification, text-based retrieval, attribute-based recommendations, and multilingual image recognition. Thank you.